Hi, and welcome to another video doing a function of the assignment 6 in topic 6. And the function we're going to do right now is sorting. And so we need to actually, like we did with shift to positive and shift to positive in place. So we have two versions of it, shifting to positive, returning an actually shifted to positive copy of the array, and then one that actually mutates our array. Likewise, we will have the same for sorting in place, so sorting the actual array given to the function, and returning a copy with the sorted function of the array. Now about sorting, that's actually a subject focused on by courses like algorithms and data structures. We're just doing the basics of programming. So let's see what the assignment says about sorting. Take a look at this algorithm and try to translate the English text into JavaScript code. And the algorithm suggested is not part of the course's material or the course material, and it's insertion sort. Okay. Likewise, you could look into bubble sort and selection sort and so on. But let's do what the assignment asks from us, and let's go and fetch. And I took the liberty to already go and fetch the pseudocode in on the Wikipedia page of insertion sort. So let's do this. I need, and you might have noticed that while we have the shift to positive on a copy and then in place, the order of sort is the other way around. So sorting is sorting in place and then we sort on a copy. And well, this is not a coincidence, because sorting in place oftentimes is done in an easier way for some algorithms than if you were to do it in a copy. Let me give one example. If you, for instance, search the smallest number in an array and you want to put it up front, then you can easily swap the smallest number with the number in the front and then repeat this process from the second number or the second position on in the array. Again, looking for the smallest one and swapping that with the element where you started, which is now the second element. And so the second element will be the second smallest and in place. So doing that in place is easier, because if you were to do it in a copy, then you can find the smallest number in an array, put it in front of your first copy, but it's not gone in the original array. So how would you find the second smallest? And that would be hard to do. So actually doing this, and that's the algorithm I'm talking about now, is selection sort, is easier done in place than it is on a copy. Okay, but no problem. What we're going to do is we're going to do it in place, and then we can pull the same trick by doing by calling the in place version on a copy and then returning the copy. Okay, so that's easy. Let's do the copy function, the sort function, okay, on an array. And that's going to be easy. I'm going to put the pseudocode here, okay, that I got from Wikipedia, but I can easily do something like this for the sort copy, because the sort copy will now be very easy. Sort copy on an array will be nothing more than, and that's the sorting but returning a copy, so not sorting the original array, and it would be something like this. I get a copy of the array, for which I built a copy function in the earlier videos, right? There it is on line 75, and then I call the in place function, so that would be sort. That actually mutates the copy, and then we return the copy. So sort copy is done. Now let's look into the sort. And this is the algorithm. Let's see if we kind of see what's happening. And well, this insertion sort is basically doing what? I'm going to show you this. Let's say I have an array, okay, and I have 9, 7, 5, 4, 3, 1, 6, 8. I think I have all of them. No, let's add a 0 as well. So I didn't use commas in between, but you get the drift. I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 in there. So this is just an example. This is how the algorithm goes. I need to start thinking of this array in two pieces. So I'm going to, in my mind, somehow divide the array in two pieces like this. Okay. And I'm going to say, well, let's consider the first part of the array after the 9. And we are going to assume that this side of the array is sorted. And it is, because it only contains one number. And then I'm going to do what? I'm going to shift my border or my split to the next number. So this goes like this. What if, so I had first this is sorted because it's only one number. And now what if I'm shifting the divider between those two arrays to the next level? So one more number gets to the left. This isn't sorted anymore, but I'm going to consider this 7 as being an empty spot. So I can actually get it out. Okay. And of course, 7 will be still there. I'm just holding the thought that I can override the 7. It doesn't matter to me anymore. And I will hold it in some temporary variable. Okay. 7 will be in my temp. And now we can say, as long as my numbers on the left hand side of this question mark are bigger than 7, I'm going to shift them. So I'm going to override this cell with the cell on the left. And if I get to some position that doesn't have a smaller or bigger number on the left, or has no number at all, like here, I know that this will be my empty spot now, where I can fill in my temp. And 7 will go there. This will become clearer if we do one more step. Let me do one more step. So let's now assume that I'm going to shift again my divisor to the right, and I'm going to decide that 5 now is an empty spot. Okay, so I set aside 5 in my temp variable, and now I can decide that this is an empty spot, and I'm going to do what? I'm going to check if my number on the left is bigger than the 5 I put aside, and it is, so 9 is going to get copied here. And at this point I don't need this 9 anymore, so I can consider it as the empty spot. And 7 is now smaller or bigger than 5, so 7 has to shift as well. So here we go. And then by that operation, I don't need this 7 anymore. I can consider it my empty spot. And now I don't have any numbers on the left, so I certainly don't have any larger numbers on the left, so 5 needs to go there. Okay. And likewise, if I shift, 2 will end up here. Okay. And let's now see what the algorithm does with the 2 in place, and now we need the 4. So I will take out the 4. Now 4 becomes my empty spot, and I kind of remember that the divisor is there now. 4 is set aside, so I consider this my don't care, an empty spot. 9 is bigger than 4, so I have to copy the 9 to the right, to the empty spot. And now this is the empty spot, so the spot I don't care about because I already have set aside the 9. Same for the 7. 7 is bigger than 4, so 7 goes in here. And this now is my empty spot. And also the 5 has to shift right. And now I have a number that's not larger than 4 anymore, so I can safely fill in my 4 in this empty spot. And that's how I basically shift my divisor. It's not really there, so it's in the algorithm. We have to keep track of the divisor, and I kind of throw one by one each number to the right, and I shift it to the right spot. So I insert it in the right spot, and it's in place. And the in place is done by actually looking at the array as a divided array with the left hand side sorted and the right hand side still to sort, numbers to sort. Okay, so now that I explained this, let's see if we can make sense of the algorithm. So this is clearly a while loop for the whole length of my array, starting at 1, because of course I consider the 0th element, the element at index 0, I consider it already as sorted, and it's incremented one by one, and this is the end of the while. So I can basically write a while here. While, let's do a 4, okay, why not? Let's do a 4. So for all numbers from 1 to the length of the array, okay, so that's it, and this should be the body of the 4 now, okay. So let's take it one step at a time, and I'm just translating now. So if the pseudocode would be wrong, then my algorithm certainly will be wrong as well. I set aside the ith element of A, okay, so I can do that with a let. I call it temp, so let's do temp. And it's going to be the element at array index I. And then I have a new while here, okay, with some I starting at, some j starting at I, j decrementing, and I have a mixed condition. So let's write the while, okay, so, let j start at I. Okay, while, and I have some things to do there. I will have a body of the while, and at the end of the while, j will decrement. Okay, so I have done this, I have done this, I have done this, and now I need to do this. So the element at j minus 1 being left to j is copied to j. So I basically copy it like I did in the example, right? So my array at position j has to become my array at position j minus 1. And always watch the AI doing something wrong, because you have to handle it, of course. And this is what needs to be done. So, well, j is bigger than 0, and array at position j minus 1 is bigger than x. Okay, seems safe. Bigger than tmp at position j minus 1. So before I address j minus 1, so this my j is basically pointing to the empty cell, the cell which I regard as can be overwritten. But before I do that, so before I take the cell on the left and copy it to my cell j, I have to make sure that j is bigger than 0, because then j minus 1 will be 0, and that's an element that exists in my array. If j would be 0, then j minus 1 would be minus 1, and that of course would give me an error on the index, or the indexing of the array. Okay. Mind the fact that I have to check this before I check this, because of the lazy evaluation. So if this is true, then he will check this as well. But if this is wrong, so if this is false, he won't bother checking this. So this will never be a problem because of the lazy evaluation. So you cannot turn it around, even though mathematically it would be the same. In programming, it is not. So I've done this. Okay, I've put in the while. You could write it as a for, but you would have a mixed condition in the for, and that's not as clean. So I'll leave it with a while here. And then finally, I have to do this. If I stop shifting my j, then my array at position j will be, of course, whatever I put aside. Okay. And then I'm good because I already incremented the I here. So that should be the algorithm. Let's see if it works. Let's see if sorting works. And it does. And then my sort copy should work as well because it's quite easy to understand. Make a copy, call my sort on it, and return the sorted copy. That's it for the sorting. Again, you're not supposed to understand or to come up with these algorithms yourself, but if you've been given an algorithm, you should be able to translate it in JavaScript. Luckily, we have the algorithm in pseudocode, so it was basically a straightforward translation. Okay, so for each number starting at 1, what I'm basically doing is I'm considering this my element that should be inserted to the left of I in the right spot. So therefore I start at I, and I can't see as long as I have a j next to me, and that's a number that's bigger than TMP, I have to shift the left hand value to my cell, and I have to switch or go left with my j. So I basically moved the number to left of me when I'm j, I'm the empty cell. I moved the number left of me to my cell, and then I'm just going to the cell left of me. Okay, so I kind of shifted the number in j-1, and now I'm going to j-1 as the next empty cell, and I'm doing this as long as I find numbers that are bigger than the number I finally will have to insert, and that's what I'm doing if I'm done shifting numbers. Okay, that's it for sorting, and that's it for the whole assignment.